Hello, good day. I'm Engineer Ernesto C. Prudenciado Jr. and I will discuss today the basic of sine and cosine and their respective graphs. And at the latter part, I will also discuss the solution of right triangle. Okay, so let's start. Okay, so have you ever wondered, class, if where is the word sine and cosine started or originated? So to myself, I also wondered that for a long time. So I made a short story, I made a research so that you can have or we can have an idea about where the name sine and cosine originated. Okay, so long time ago in India, okay, so it is started in India around 240 to 550 AD in Gupta period, no? So, mathematician there asking what is the relationship if you have a circle and you have 2 points around the perimeter of the circle. So, okay, we'll move here. We'll move here along the perimeter or along with the circle. Okay, so of course this will be variable. This will vary along the way. Okay, this chord, no? So when they found that it is like a bow and arrow, so they call that as Jaya or Jiva. Okay, so it means in English it is a bowstring. Okay, so since at that time India is very dominant in terms of knowledge and research, no, especially in mathematics, so their dominance radiated to the whole Middle East and up to Persia, which Persia is using Arabic language around 700 AD. So they translated that Jia or Jiva into Jiba, okay, in Arabic. But Arabic people are very known for making the word very short, so they usually cancel out the vowel, so it pronounced there as jib. Okay, jib. So when the globalization started, so the Western or European started to make trade to Middle East, no? So some of the Western European translator around 1100 to 1200 AD, okay, in the name of Robert Chester, okay, he's the one first ever translated from the Quran, which is Arabic, to Latin. Okay, so he found a book, an Arabic book, and in English the Compendious Book on Calculation by Calculation and Balancing. Okay, the basic concept of sine and cosine. But since it is Arabic and it called jib, okay, so he translated that since he knew that Arabic people are usually making the word short, so he translated it as Jeba. So instead of the original Jiba, he thought that it is Jeba. Okay, so with is in terms of English, it means small bone or bosom. So, but he will translate that to Latin, and he translated that really to sinus because he thought it is Jeba, small bone. So sinus, from the our part of our nose, it's sinus, no, it's just a small bone. So because it is in Latin, it is called sinus. Okay, so since the Roman empires, no, it is very dominant at that time. So their science, their mathematics was also adopted in all over the world at that time. So when translated that to English, so this becomes sine. Okay, and the cosine word is just the complement of sine, meaning all about the other things that are not sine, it is cosine. Okay. So the short, it is just short of complementary or complements of sine. Okay. Okay. So okay. During that time, the Indian mathematician were asking what is the relationship of that point, no, and in the perimeter of the circle. What is the relationship of their height, no, as they go along to the circle? So I just somehow copy or remodel what they thought at that time, no. So I write here a triangle that is 30 degrees from the horizontal, 40 degrees and 60 degrees, 90, and so on and so forth. Okay, so let's just say this is 1, this is also 1 unit, this is the radius of the circle also. Okay, so but in this time, this is also the hypotenuse of this triangle. Okay, so if you measure this height, no, and divide it by hypotenuse, which in this time it is 1, so this will give me 0.5. Okay, so in 45 degrees, if you measure this height over this hypotenuse, this will give me 0.707, but I just didn't write this, no. So this will give me, this height will give me 0.707. Okay, so in 60 degrees also, this will give me 0.87. Okay, so at 90 degrees, this will give me 1. This is the highest point, no, since the sine or the sinus or sine, no, or the jiva is the ratio of the height of this triangle over the hypotenuse. So up to 90, the height of the triangle is this, 90 over the hypotenuse also is this. This is coinciding the height of the triangle and the radius of the circle. Okay, so that is 1 over 1. So this will give me 1. Okay, by symmetry, so this will 120 degrees will give me also 0.87, and 150 degrees will give me also 0.5, no. So if you continue to draw the graph, no, from the angle below the x-axis, this will give you a negative value since the height here is below the horizontal axis. So this is called the sine wave. So this is the graph of the sine wave, and if you continue, this will give you symmetrical line. Okay, so when you draw also the cosine, this is the graph of the cosine, and this is cosine wave, no. So since why is it that 0 here, the origin, it is already 1. So since the cosine measures this distance or the adjacent, okay, over the hypotenuse, so this one is the adjacent, and when the triangle is at 0, so this is the adjacent, and this is also his hypotenuse. So this height or this adjacent, which is equal to 1 over the hypotenuse, is equals to 1. So 1 over 1, this will give you 1. Okay, so you can draw along the way, so you can have this graph of the cosine wave. Okay, okay, since we already discussed the basic of sine and cosine, we will now go to the solution of the right triangle. Okay, so this is also related to what we have discussed already. Okay, so suppose I have a triangle here. Okay, a right triangle, because one of the corner is 90 degrees. So this is my opposite, this is my adjacent side, and this is my hypotenuse. Okay, so it is denoted as A for the opposite, and B for the adjacent, and C for the hypotenuse. Okay, so the sine of that, and this is the theta. Okay, so the sine for that is sine of theta is equals to the opposite over the hypotenuse. So that is this is the same of what we have discussed in the previous, this one. So the relationship of the height and the hypotenuse, so this is called sine. Okay, so this time in this triangle we will also do the same. The sine theta is equals to the opposite over the hypotenuse, or A over C. Okay, A over C. For the cosine, that is B, or the adjacent over the hypotenuse C. The adjacent over the hypotenuse C. So this is B over C. Okay, and I shall introduce to you another trigonometric function. It is called tangent. It is just this opposite over adjacent. Okay, opposite over adjacent. So A over B. Okay, A over B. Okay, so those are the basic concepts of trigonometric functions. So since it is very lengthy solution and lengthy to memorize, I will recommend to you that you just have to memorize this, Sohcahtoa. This is the summary of these three formulas. So this is just very short. You just have to memorize Sohcahtoa. So what does, or what this Sohcahtoa means? So means is sine is equals to opposite over hypotenuse. Sine is equals to opposite over hypotenuse. Okay. How about ka? Ka is the cosine of adjacent over hypotenuse. So ka is equals to the adjacent over hypotenuse. Okay, so toa is tangent is equals to opposite over adjacent. Opposite over adjacent, so tangent theta is equals to opposite over adjacent. Okay, so if you are going to memorize this, so this will be your shortcut. Okay, so this is very easy to memorize. Okay, so I will introduce another concept or another solution to right triangle. This is called Pythagorean theorem, developed by a great mathematician, Pythagoras. So I have a triangle here that I will denote A. The opposite side is A, the adjacent side is B, and the hypotenuse is C. Okay, so the theorem states that the square of the area of the square whose side of the hypotenuse, this one, is equals to the sum of the areas of the squares of the two other sides. So these are the two other sides, A and B. Okay, so in mathematical equation, it is A squared plus B squared equals C squared. Okay, so this formula also has a lot of proof. So I will just choose, or I will derive one of the easiest derivation of that formula, no? So by just drawing this figure. Okay, so let's say we have a square here. Okay, and we have also a smaller square inside the big square. This one, this is the smaller square. So if I will write the basic area of a square, so I will say area big AB width times the height. Okay, so width here is A. I will just say A plus B, no, multiplied by the height here is the A plus B also. Okay, or I will just simply write this as AB squared. Okay, so the area of the small square, no, is the C, or this is also width times height is equals to the width here is C times the height also is C. So this will simply gives me C squared. Okay, so how about this area of the triangle, the small triangle? Area of the triangle is equals to 1/2 base times height. Okay, so this is 1/2. What is our base? A times height here is B. Okay, so this will simply gives me 1/2 AB. Okay, so what is now the relationship of these three? So this time if I will subtract the small square from the big square, so big square minus small square, that will give me this 4 triangle. Okay, so again, this big square will be subtracted by this small square, so this will give me this space or this area, which is, what is that? That is 4 times the area of the triangle. This is 4, 1, 2, 3, 4. Okay, so 4 times the area of the triangle. Okay, so this is equals to, if we substitute AB here, A plus B squared minus area of the small square, this is C squared, equals to 4 times the area of the triangle is 1/2 AB. Okay, so I will continue here. So this will gives me the expansion of a binomial term is A squared plus 2AB plus B squared. Okay, minus here C squared equals, this one will give me 2, excuse me, so 2 times AB. Okay, so this will cancels out, so what will give me is A squared plus B squared minus C squared equals 0. Okay, so rearranging this equation, I will transfer this negative C squared to the right of the equation, so this will give me A squared plus B squared equals C squared. So this is now the final formula, and since this is equal to the given equation in Pythagorean theorem, so this formula is proved. Okay.